Now I'd like to introduce our next keynote speaker. Gary Dickerson is President and CEO of Applied Materials, the leader in materials engineering solutions used to produce virtually every new chip and advanced display in the world. Please welcome Gary Dickerson.
Thanks, Dave. Welcome to everyone attending today, and congratulations to SEMI on their 50th anniversary. This time last year, many of us gathered together in San Francisco to talk about a new era of growth. Whether we call it the intelligent age, the data economy, or the AI era, this inflection has the potential to transform every industry, including our own. I don't think any of us would have predicted what was going to happen in 2020. COVID-19 is an unprecedented challenge that is affecting everyone on the planet. As communities, companies, and individuals, we've never faced anything like this in our lifetimes. While we all owe a debt of gratitude to the medical professionals on the front lines of this pandemic, I think we should also feel a strong sense of responsibility being part of the electronics industry. From putting AI and big data into the hands of researchers seeking treatments and vaccines, to the communications and cloud technologies that are keeping the global economy running, the world is relying on semiconductors more than ever before. This year's conference is very different, and we'll miss catching up in person. However, this virtual event is a great example of the enabling power of semiconductors and how new ways of working not only provide solutions today, but create significant benefits over the long term. Just think about the technology that makes this virtual conference possible. I'm talking to you from a studio at Applied's headquarters in Santa Clara, California, and I'm going to be joined by friends and colleagues in Taiwan and Singapore. Our voice and video is being transmitted through a complex network of routers and servers up to the cloud and then down to the laptop or tablet you're looking at right now. By my calculations, it takes a quintillion transistors, that's 10 to the power of 18, to make this conference work. Every single one of those transistors has been designed, developed, and manufactured by the companies represented here today. And we're only getting started. These technologies that are enabling work from home, schooling from home, and e-commerce will continue to improve. I'm definitely excited about those trends, but what I'm even more excited about is what comes next. AI and the data economy will change everything, every industry, every aspect of our lives. The very foundation of competition will be transformed. By 2030, there could be 500 billion connected devices at the edge, and data generation could grow to half a yottabyte a year. That's 10 to the power of 25 bytes of data. Almost all that data will be generated by machines and then consumed by machines. As we move from an application-centric world to a data-first world, growth will not be limited by humans' ability to create or consume data. At the same time, this explosive growth in data generation, storage, and processing has the potential to change the world's energy equation. Over the past 50 years, semiconductor technology has changed the world. This industry has blazed a trail in innovation, trying new ideas and reimagining how things can be better. I strongly believe we're in a privileged position to shape the future. I also believe that it's our job as leaders to leave the world in a better place. And that brings me to the topic of my talk today, our vision to make possible a better future. Before I describe the actions we're taking to drive this vision, I wanted you to hear from another industry leader I deeply admire about how they see the future.
Gary, thank you for inviting me to this event. Ladies and gentlemen, as we move from a digital age to an intelligent age, the semiconductor industry continues to expand the capability of semiconductors to enrich people's lives and serve people around the world. TSMC is committed to developing technology to unleash innovations, and we believe technology is the key to bring prosperity and happiness to the society. However, progress in technology and growth in corporate business are only meaningful in a sustainable society and the environment. At TSMC, green manufacturing is not only deeply embedded into the way we work and the way we think, but also a commitment to society. We continue to push forward with our Green Fab and green manufacturing initiatives. Applied Materials is a key member of this initiative, and this work demonstrates how we can innovate together to reduce emissions. I would like to thank Applied Materials for the partnership and leadership in this area. It is critical that we work together across the industry to share our experience in sustainability, broaden our impact on society, and realize our common goal of an environment in harmony with technology. Let's continue our work to drive to a better and sustainable future for everyone. Thank you.
Thank you, CC. We greatly appreciate your leadership and support, and we're glad to be taking this journey with you. And as we think about that journey, let's start by understanding and assessing our company, how we operate, how we conduct our business. In 2019, Applied's carbon footprint was the equivalent of 145,000 metric tons of CO2. These are Scope 1 and 2 emissions and dominated by the power it takes to run our labs and factories. Then, we think about how we partner with our customers and suppliers. Semiconductor manufacturing generates 50 million metric tons of CO2 per year. Finally, we think about how our technology is ultimately used. In terms of magnitude, global electronics, all the PCs, tablets, servers, routers, smartphones, and so on, generate almost 1 billion tons of CO2 annually. We call this framework 1x, 100x, 10,000x. 1x, our direct impact and how we run our business. 100x, the industry's impact, including our customers and suppliers. 10,000x, how our technology can be used to advance sustainability on a global scale. So let's get started with the 1x category and some important context. We're in a fortunate position because the opportunities for our industry have never been greater. SEMI and VLSI expect annual semiconductor revenues to grow to $1 trillion by 2030. Over the past 20 years, the industry has doubled in size, and we now expect it to double again, but twice as fast. Now, I'm not going to give a 10-year forecast for wafer fab equipment, but if we do some basic math and calculate a range based on WFE intensity, that's semi revenues divided by WFE investments, we get an envelope of $100 billion to $130 billion. For the past 5 years, WFE intensity has averaged 11.5%. So I think this range is pretty reasonable. This means the first thing we need to do is decouple our growth from our environmental impact. If we double or triple the size of our company, it would be irresponsible to double or triple our carbon footprint. Applied will not increase environmental impact in line with our business growth. Today, we're making a commitment to new sustainability targets for the next decade that will dramatically reduce our impact. These goals are aggressive but achievable. First, we will move to 100% renewable energy in the U.S. by 2022. Second, we will move to 100% renewable energy globally by 2030. And third, we pledge a 50% reduction in our Scope 1 and 2 CO2 emissions by 2030 compared to our 2019 baseline. In addition, we're signing up to science-based targets and will set goals for our Scope 3 emissions in the next 24 months. And finally, we are committed to support the Task Force on Climate-Related Financial Disclosures, the TCFD. While I'm talking about Applied's commitments, I also want to take a moment to speak about something very important to me, my family, and many of you watching today. Recent events in the U.S. and beyond have been a wake-up call that we cannot be complacent about the inequalities and discrimination that mark too many of our communities. At Applied, we welcome diversity. We embrace different perspectives as a key to innovation. And we believe that we are stronger when we stand together against racism and discrimination. Words are important, but what really counts is taking action that will have a lasting impact. This is what we pledge to do at Applied to make a real and sustainable difference. First, we will be transparent. For the past several years, we've published our representation data. It's all on our website, and we will continue to do so. We want Applied Materials to reflect our changing communities, and we're committed to bring more women and underrepresented minorities into our team at all levels of our company. Second, we will set clear targets for the goals we want to achieve in terms of recruiting and retaining underrepresented minorities. Third, we will ensure that all our employees are trained and empowered to listen, learn, and take action. We want to ensure that Applied in our industry set a standard of what it means to be a more welcoming, inclusive, and collaborative community, where all people can do their best work and have the opportunity to succeed. Now we will move beyond our carbon footprint and diversity and inclusion initiatives at Applied to the next level of our framework, 100X, which is about how we can positively impact industry-wide sustainability. Before I talk about the solutions Applied has been developing, I'm going to ask Dr. Sarah Boyd, who is a senior consultant at Sphera, to provide us with her Semiconductor Sustainability 101 in 90 seconds. Sarah, welcome to SEMICON, and over to you.
Thanks, Gary. As many in the audience may know, there are more than 1,000 semiconductor fabs operating globally today. Together, these factories produce $450 billion worth of chips a year and about 50 million metric tons of CO2. In semi-manufacturing, our carbon footprint is made up of Scope 1, which is fab direct emissions to air, Scope 2, electrical energy use, and Scope 3, energy related to the consumption of process chemicals and consumables produced by suppliers upstream. Considering all these aspects, with direct emissions properly abated, by far the largest component of a fab's carbon footprint is Scope 2, electrical power. Let's consider an advanced fab with a capacity of 50,000 wafer starts per month. That fab is consuming roughly a terawatt hour per year, close to the electricity use of a city of 100,000 residents, like Santa Clara, California, for example. When we break that power usage down, about half is directly consumed by the tools themselves, and the rest is used to run the tool support systems, facilities, and clean room. And that is the industry's sustainability challenge in a nutshell, Gary. I hope that is helpful.
Thanks, Sarah. That's a great setup. As we work with our customers, there are 3 main initiatives we are driving. First, we're improving the eco-performance of our products. An easy way to think about this is that a typical advanced process tool in high volume production consumes about 1 million kilowatt hours of equivalent power a year. To improve eco-performance, we've developed hardware and software upgrades to reduce energy and process chemical use. Many are available as upgrades for the installed base as well as in our new tools. Second, we've developed advanced service products that help customers optimize their installed base eco-performance, as well as shorten ramp times, improve device performance, yield, and cost. Our service group works with customers to tune their systems to peak performance. Third, our next generation of tool architectures significantly improve throughput density. That's the number of wafers processed for a square foot of cleanroom space. We've set an ambitious goal that we call 3 by 30. On a per wafer basis, we're going to drive a 30% reduction in equivalent energy consumption, a 30% reduction in chemical consumption, and a 30% increase in throughput density per square foot of cleanroom space, all by 2030, averaged across our semi product portfolio. Making improvements of this magnitude and at the same time driving the technology roadmap forward is not easy and requires deep partnerships with customers. So let's hear from one of them that is leading the way in environmental responsibility.
At Micron, our vision is to transform how the world uses information to enrich life for all. We embrace our responsibility to do this through the products that we develop and by ensuring the sustainability of our operations. We have identified a multi-pronged approach to combating climate change. We are developing more power-efficient products that can enable new, high-performance computing architectures with dramatically lower power consumption. The scaling of our technology nodes delivers greater memory capacity from each kilowatt hour of energy consumed in our fabs. Every year, we increase bits per wafer by a higher percentage than the resources required to produce that wafer. Finally, we are investing 2% of our annual CapEx, amounting to approximately $1 billion over the next 5 to 7 years, to enhance energy efficiency, greenhouse gas abatement, as well as waste and water recycle infrastructure at our facilities globally. We are also integrating sustainable design into our future node development. By starting early with our partners, including Applied Materials, we can enable the processes and factories of the future that will help us create and realize a more sustainable world.
Thank you, Manish. At Applied, we're passionate about this topic, and we want to work with companies who share our vision and goals. As well as working closely with customers, we're also making important changes to the way we partner with our supply chain. Today, we're pleased to announce our Success 2030 program. This is our shared 10-year roadmap, and there are 3 key components. First, we're going to hold our supply chain to the same standards that we hold ourselves in the areas of environmental impact, labor standards, and diversity and inclusion. We're introducing a sustainability scorecard into our supply chain selection process alongside our traditional metrics for performance, cost, and quality. Second, we're going to improve together handoffs between our suppliers and us. Here, the call to action is reduce, reuse, recycle. And third, we're going to partner with our suppliers to share best practices and key learnings. The response has been great, and we have 6 key partner suppliers already signed up to help us kick off this program. Thank you to all of these companies for sharing our vision and passion to make possible a better future. I also want to deeply thank all of our suppliers for stepping up during the COVID crisis. We really appreciate it. COVID-19 restrictions have stimulated many changes in the way companies in the industry are operating. While these actions are being driven by the need to achieve our near-term goals, I'm very excited about the long-term benefits of working in new ways, especially remote support and remote R&D. In a traditional way of working, flying an engineer from the US to Asia and back generates about 2 metric tons of CO2. Further expanding secure data sharing to enhance remote support and remote development is a major opportunity for the industry. I strongly believe that Innovate Anywhere should be a significant and permanent change to the way the industry operates. It's a game changer. Over the past several years, Applied has made significant investments in state-of-the-art digital infrastructure, sensors and metrology, data science, machine learning, and simulation. The combination of these technologies enables us to reduce product development cycles, speed up transfer of new technologies from lab to fab, and optimize cost, output, and yield for our customers in volume production. While operating our businesses the right way is incredibly important, our impact on the world goes well beyond our own labs and factories. When you think about the world's grand challenges, about how we make the world a better place, semiconductor technology has a critical role to play. Today, I will focus on one specific theme, AI, because AI has the potential to change everything. It can provide us with the analysis, prediction, actionable insights, and decision-making capabilities well beyond the abilities of human thinking or traditional computing. We can accelerate research to better understand climate change, diseases, and public health. And smarter manufacturing, smarter healthcare, smarter vehicles can create a safer, more secure world where we optimize the use of precious resources and reduce waste. The applications and possibilities are endless, but AI has an Achilles heel that, unless addressed, will prevent it from reaching its true potential. That Achilles heel is power consumption. Training neural networks is incredibly energy intensive when done with the technology that's available today. Last year at this event, I shared our perspective about the magnitude of this problem. Since then, we've worked with our partners to refine our assumptions. Today, traditional data centers consume about 2% of the world's electricity. Our models show that if we build out AI data centers using current generation technology, they could potentially consume 15% of the world's electrical power by 2025. This model is dominated by a new and fast-growing workload, training AI models with visual data. But there's good news. This is a chart that I first showed 2 years ago that describes the gaps between computing solutions that are currently available for AI and where performance needs to be. At the time, we said there was a 1,000x improvement needed in the compute performance per watt for training in the cloud. When we update this chart for 2020, you can clearly see progress is being made, but there is still a long way to go. The other good news is there is a lot of promising new technology in the pipeline and a vibrant ecosystem of innovators, including many new startups, focusing on accelerating innovation at the edge and in the cloud. Customized design will be critical. New system architectures, new application-specific chip designs, new ways to connect memory and logic, new memory technologies, and in-memory compute can all drive significant improvements in compute performance per watt. To unlock the potential of edge and cloud technologies, major advances in the power, performance, and area cost, or PPAC, of semiconductor devices are needed. This playbook has 5 elements: new system architectures, new devices and 3D structures, the introduction of novel new materials, new advances in 2D geometric shrinks, and new ways to connect chips together through advanced packaging. Based on recent input from customers, we've updated our PPAC framework to PPAC-T, where T stands for time to market, acknowledging the enormous value of speed. Applied has by far the largest and broadest portfolio of technologies and products to accelerate the PPAC-T playbook. which spans creating, shaping, modifying, analyzing, and connecting structures and devices. Let me give you an example. Using a product that we're launching today that illustrates how a new materials engineering technique, selective deposition, is being used in conjunction with advanced lithography and patterning to improve PPAC in leading-edge logic devices. Transistor innovations in materials and structures is driving higher and higher performance. However, as the wiring inside the chip gets narrower, electrical resistance grows, increasing power consumption and impacting performance of the chip. The modern transistor becomes like a finely engineered race car stuck in traffic. The most critical issue today is at the contact, which is the wiring that connects the transistors to the rest of the chip. Until now, the contact wire has been formed by creating a via in the dielectric layer above the transistor, cladding the via with a titanium nitride liner, and adding a tungsten nucleation layer. These act as a mold as the via is filled with tungsten. Unfortunately, that mold doesn't scale, and it's taking up a larger percentage of the via space. New innovation was needed, and our solution was to eliminate the mold altogether. It's like going from injection molding to 3D printing at an atomic level. Our selective deposition technology creates thicker contact wires, which is like widening the roads again for our race car transistor. This seems like an obvious solution, but in reality, it's incredibly difficult to do. We need to create an ultra-pure environment that's hundreds of times cleaner than the clean room. We need to carefully pre-treat the surfaces. Then, we need to selectively grow the tungsten atoms so they perfectly fill the via from bottom to top. There are hundreds of billions of contacts across the wafer, and they all need to be perfect. So the entire process flow takes place under ultra-high vacuum to keep impurities out and to optimize material structures and interfaces. This next generation of equipment, which we call integrated material solutions, is one of the ways Applied is bringing to bear our broad technologies and capabilities to address our customers' most complex challenges. As I wrap up here, I want to again emphasize that I strongly believe our responsibility as leaders is to leave the world in a better place. At Applied, we're taking actions that are aligned with our vision to make possible a better future. Today, we announced our goals to move to 100% renewable energy and reduce our own carbon footprint by 50% over the next decade using science-based targets and transparent reporting. We're working with our customers to increase the performance of our tools, eliminate waste, and drive productivity. We launched a new 10-year roadmap for supply chain sustainability, our Success 2030 program. And most significantly, we focused our company, our strategy, and our investments to build a strong pipeline of meaningful innovations that will accelerate the PPAC-T roadmap and enable sustainable AI. To achieve our potential across our industry and the electronics ecosystem, we need to think and act differently. We need to break down barriers from materials to systems and connect dots in new ways between system designers, integrators, chip makers, equipment, and material suppliers. The challenges the world is currently facing are an accelerator for key technology inflections, and we will see significant and permanent changes in the way companies operate. So my call to action for all of you is to innovate anywhere and collaborate everywhere, and join us as we make possible a better future. Thank you.